Welcome everyone, my name is Pramod Bisal and in this video we are going to discuss about solving numerical questions without using calculator. Because in most of the competitive exams these days, especially for engineers, they ask a lot of numerical questions but calculator is not allowed. So if you are preparing for any of these exams, especially UPSC ESE Prelims, PSU exams, ISRO BARC, SSC-JE RRB-JE, in all of these engineering competitive exams, there will be a lot of numerical questions and you have to solve them without using calculator. So what should be your approach so that you can get accurate and correct answers, that we are going to discuss in this video, starting with certain numbers and values that you should remember so that you can do faster calculations and you can save some time. Then we will discuss about elimination method and hit and trial method. So after taking a look at the options which are given to us and the calculation that we are doing, how to do elimination and how to use hit and trial, that I am going to explain. If hit and trial is not possible, if elimination is not possible, then how to do approximation in our calculations. Okay, so I will give you examples of that. And sometimes it happens that a question seems very complex when we take a look at it because of the numbers and values given in it. But in reality, that calculation is very easy. So I will give you examples of those easy questions also, which may seem complex at our first glance. And in the end, we are going to discuss about certain conditions under which you should leave a question without solving it completely. Because in every exam, there will always be some hard questions which are not meant to be solved because they are going to consume a lot of your time and you cannot afford to give that much time to a single question. So it is wise to leave these questions initially, and in the end of your exam, if you are remaining with some time, then you can come back and you can try to solve them again. Okay, so that is the wise thing to do. Now, all of these tips I am going to implement in actual questions asked in ESE 2020 Prelims of Mechanical Engineering. So this video may get a little longer because I am going to actually implement and solve the questions with the help of these tips. Okay. Then finally, I am going to give you bonus tips that you can implement in your numerical and calculations so that you can get accurate results. So let's start with certain values and numbers that you should remember. The very first number that is used very frequently in all of the engineering fields is pi. So for pi, first you should try to use 22/7 instead of 3.14 because the fraction values are easier to solve because you might cut some values in there and you can get an answer faster. Okay, so try to use 22/7. Then everything related to pi you should remember. For example, pi square, which comes out to be 9.87, but you can approximate it as 10. Okay, so 10 is almost equal to pi square, which is also equal to g value. Okay, so somewhere in your example, if there is g value and pi square, then you can simply cut them with each other or you can approximate them with 10 value. Okay, similarly 1 by pi should be 0.318 because pi into pi is 10, so 1 by pi will be somewhere 0.318. These are the numbers related to pi that you should remember. Other than this, there should be some square roots that you should be remembering. So right from 1 to 10, all of square roots, they should be in your mind. At least root 2 and root 3, these two numbers are very important. Then all of the fractions up to 10, like 1 by 2, 1 by 3, 1 by 4, up to 1 by 9, you should be remembering. All the squares up to 20, you should remember. All the cubes at least up to 10, you should remember. You can increase the values, but at least up to 20 squares and at least up to 10 cubes, you should be remembering. Then there are certain formulas that you can implement, like sine theta for smaller values of theta is almost equal to tan theta, and that is almost equal to theta. So you don't really need to remember sine values and tan values. You can simply approximate it with this particular formula. At the same time, there is a formula for log values also. ln 1 minus x is almost equal to minus x. These formulas you can implement in your calculations to do faster calculations and to save some time. Okay, now let's solve some questions and implement the tips that we discussed about, starting with the elimination method. Well, for the elimination method, we are going to start with question number 68, and I am assuming that you know the concept and you will get the equations. So I will right away start with the calculation part. Okay, so in this question, we need to calculate values of Q1 and Q2, and the two equations that we need to solve are Q1 plus Q2 is equal to 0.25 and Q1 square divided by 0.8 raised to power 5 is equal to Q2 square divided by 0.6 raised to power 5. Now solving these two equations in exam within limited time with accuracy is next to impossible. So what we are going to do here, we will take a look at first equation only and then we will compare all the options against this equation only. Okay, so let's see. In option A, the summation will be 0.27. In option B, the summation will be 0.33. In C, it will be 0.57. In D, it will be 0.63. Now, can you see which will be right answer? you can automatically imagine that option A is the only answer which is satisfying our first equation. So we don't really need to solve these two equations. We can simply do the elimination of these options and we will have our A as correct answer. Okay, now let's take a deeper look at the calculations within elimination, how exactly we can do with the help of another example. Now the second example that we are going to solve over here is question number 122, and the calculation that we need to do here is 0.0095 is equal to 0.622 PV divided by 1.013 minus PV. Now it may be easier for you, it may be complex for you, but still I am going to explain it in view of elimination method. Okay, so we will do the cross multiplication and everything. So we get 9.5 multiplied by 1.013 minus PV is equal to 622 PV. And when we solve this, I can say that 9.5 into 1.013 is somewhat 10. Okay, so 10 is equal to 631.5 PV. Okay, so the value of PV is equal to somewhat near to 10 divided by 631.5. That is the PV that we need to solve. Now all the options are in 3-point decimals. So what I'm going to do, I'm going to simply multiply it by 100 and all the options also by 100 so that I can do the comparison very easily. So PV value is equal to 1000 divided by 631.5. Okay, now there is only one option which can satisfy this calculation, and that is option D of 1.6. When we do 631.5 multiplied by 1.6, we can get a value near to 1000. Otherwise, in option B also, C also, A also, we can never get this calculation satisfied. Okay, so that is how we can do elimination of all the options, because there was only one option which could satisfy our calculation. Now we will take a look at another example also so that you can understand it in even a better way, how exactly you can do elimination in deeper and more complex calculations. Okay, now one more example that we are going to take under elimination is question number 57, and the calculation that we need to do over here is the value of D, which is 6 and root over T value, and T is 1 into 1.5 divided by 2 into 83 into 0.75 multiplied by 1000, because it is in meters. We are going to convert it into millimeters, plus 2, which is also under a square root. So the very first thing that I'm going to do over here is cut 1.5 and 0.75. So I get 0.5 over here. Then 0.5 multiplied by 2 will give me 1, and the only thing that I'm remaining with is 6 under root 1000 divided by 83 plus 2. Now either I can ignore the 2 or I can consider 2 and then do the calculations. So let's consider it because it is not very hectic. So it comes out to be 1166 divided by 83. Okay, now some number is getting multiplied by 6. Now let's take a look at our options. Number one option is something 6 multiplied by, let's say 1.3 or so. Second option is 6 multiplied by a number which is less than 4. Third one is 6 multiplied by 6. Fourth one is 6 multiplied by a number which is almost 7.5. Now this square root can never be 7.5, it can never be 6. Okay, still we are having two options which we need to eliminate from. Okay, so let's see what value we are getting over here. 6 multiplied by root over, assuming that this is somewhat 1200 and this is somewhat 80. So this value is almost equal to this comes out to be 00 and 30 by 2. So it comes out to be 30 by 2. So root over 15. Okay, now in root over 15 we already know that this is a number which is somewhat less than 4, and this is going to be the only correct answer over here. So B is our right answer. We can simply eliminate all other three options. So that is how we can implement the method of elimination in our calculations during the exam. Okay, now for hit and trial method, we are going to start with question number 58, and in this question the calculation that we need to do is, first we need to calculate PE value. Okay, so PE formula is given here, and this is a very simple calculation. So it comes out to be 11,900, and then the calculation that we are having is 160 is equal to C divided by 11,900 raised to power 3. Okay, now what value of C will satisfy this particular equation, that we are going to calculate. Now we can see that options are pretty far from each other, so we can do some sort of approximations here, but let's do the cube root. So C is equal to 11,900 into cube root of 160. Okay, now 11,900 I can assume somewhat to be 12,000. Okay, similar to 12,000, a little bit lesser than 12,000, and it is being multiplied by cube root of 160. Now I don't know what is the cube root of 160, but I know that cube of 4 is what? 4, 16, 64. Cube of 5 is 125. Cube of 6 is 216. So this particular value will be somewhere near 5 and 6. I don't know what this value is going to be, so let's assume it to be 5 first. So with 5, the C value will come out to be 12,000, somewhat lesser than this, into 5, and that will be 60, a little bit lesser than 60. At the same time, if we assume it to be 6, then the value that we are going to get is C is equal to 12,000 into 6, a little bit lesser than 72. Okay, kilo, because there is a kilo mentioned over here, so 1000 factor we are ignoring. So the C value will be somewhere between 60 and 72, and there is only one option which is satisfying this particular condition, and that is option A. So our option A is correct. This is how we can do hit and trial in our numerical methods also. Okay, now let's take one more example to understand it even deeply. Now in this second example, we are going to solve question number 76, and the calculation that we need to do over here is 1 minus 303 divided by 1073 is equal to 1 upon 1 plus QR, and we need to solve it for QR. Okay, that is our primary target to solve in this question. So what I'm going to get over here is 1073 minus 303 divided by 1073 is equal to 1 upon 1 plus QR. Okay, and that comes out to be 1 plus QR is equal to, this will also reverse, and 1073 divided by, I can simply do the negation here. Okay, so that comes out to be how much? How much will it be? 770. Okay, now taking this one on other side, QR value is equal to 1073 minus 770 divided by 770. Okay, so ultimately the calculation that I need to do over here is QR is equal to 303 divided by 770. Okay, now I need to see the options over here, and then I need to see which of these options can satisfy my this particular calculation. Okay, so what I'm going to do, I'm going to start with option number A. So 770 multiplied by 0.2, what I'm getting here, 2, 4 and 154. Okay, but this is 303. Now I'm going to try with the second option. Okay, so 770 into 0.4, and that comes out to be 8 and 308. Okay, so this is 303, this is 308. So obviously 0.6 is not going to satisfy it, 0.8 is not going to satisfy it, 0.2 did not satisfy it. The most accurate option or the most nearest option is 0.4 over here. Okay, so that is going to be our answer. That is how you can do hit and trial in numerical questions. Let's take one more example to understand it even further. And the third example that we are going to solve is question number 54. Now assuming that you will get the equations correct, this is going to be our equation which we need to solve. There is a 10 raised to power 3 over here also. Okay, so taking 120t common from both these factors, I will get the equation as 10 raised to power 3 divided by 120 into t multiplied by 175 divided by 300 plus 75 divided by 225, okay, is equal to 1 upon 1.5. Now I will do the cancelling out here. Okay, so it comes out to be 10 raised to power 3 divided by 120t multiplied by, so I will cut it by 25, and that gives me 7 divided by 12, right? So it gives me 7 divided by 12, plus I will cut this also with 25. This gives me 3 by 9, and that comes out to be 1 by 3. So plus 1 by 3 is going to be 1 upon 1.5. Okay, ultimately this can be 10 raised to power 3 divided by 120t multiplied by 33 divided by 36 is equal to 1 upon 1.5. So the t value, the calculation, the ultimate calculation that I need to do over here is 10 raised to power 3 multiplied by 33 multiplied by 1.5 divided by 120 into 36. That is the calculation that we are supposed to do in this one. Okay, so let's cut 1 0 from this one, and let's cut one more 0 with this decimal, and this comes out to be 5 divided by 4. Okay, so it is coming out to be 5 divided by 4. So ultimately this is 50 divided by 4 multiplied by 36 divided by 33 divided by 36. Okay, so 50 divided by 4 is nothing but 12.5, that we already know, is multiplied by a number which is less than 1, which is very little bit less than 1. So there is only one option which is going to satisfy this condition, and that is option number A, because it is having 12. All other options are more than 12, so they are not going to work for us. So A is our correct answer. That is how you can solve numericals with hit and trial and elimination method. Now let's take a look at approximation also. Now these are the questions which are little trickier to solve. The calculation may be a little lengthier, so we are going to use the approximations here in the calculations, and we cannot exactly do elimination or hit and trial here. Okay, so let's solve question number 40 over here, and the equation that we are having and the equation that we need to solve in this particular question is delta value is given to me. I need to calculate Fn value, and Fn value is nothing but 1 upon 2 pi into omega n value. Okay, and omega n is root over g divided by delta. Okay, and delta value I am already given, and which is this particular value. Okay, so 64 into 1500, and it is divided by 48 into 200 multiplied by 10 raised to power 9 multiplied by pi multiplied by 0.025 raised to power 4, and this is having a square root all over this. Okay, now the very first thing that I'm going to do is take certain things out of a square root so that my square root calculation can be easier. That will be our first step. So this gives me 1 upon 2 pi, okay, multiplied by 1 by 8, that 64 will become 1 by 8, and g, as I have told you, that g is almost equal to pi square, so I can take it out as pi, and then I am going to have 10 raised to power 9 also, so I will take 10 raised to power 4 out, so that 110 will only remain there. So the things that will be inside will 48 into 200 multiplied by 10 from this one, and then there is a pi. Also I can take 0.025 into 0.025 raised to power 2 will come out, because there is a 4 in the power over here, divided by 1500. This is the calculation that I need to do. Okay, so very first I am going to simplify this 0.025 thing. So I get 2.5 multiplied by 2.5 by absorbing 10 raised to power 4 over here. Pi will cancel out the pi, divided by 16 under root. I am having what values? So let's do a little bit solution here also. 200 will cut 2 double zeros, and then with the help of 3 I can cut it as 5, and I can cut this as 16, right? And 5 will give me 2 over here. So this is coming out to be 2 into 2 into 16. Okay, so 2 into 2 into 16 multiplied by pi. That is the calculation that I am having over here. So this comes out to be 6.25 divided by 16 multiplied by 2, and 4 will come out, so 8, and root over pi, and this 8 will give me 2, so this comes out to be 3.125 root over pi. This is the calculation that we need to solve. Now let's take a look at the options that we are having. Okay, and the value that we need to solve is 3.125 root over pi. Now which of these options can satisfy this particular condition? For that we are going to see that pi is 3.14 and root 3 is somewhat near 1.73, which we already know. So root over pi is going to be somewhat near 1.74568, something like that. Okay, so let's assume it to be 1.75 plus. Okay, so something which is just a little bit higher than 1.75. Okay, or even we can assume it as 1.7 also. Okay, so let's do the calculation here. 3.125 into 1.75, and then we will get what option is more near to our calculation. Okay, so let's do this calculation. Then I am getting somewhat 5 point something. Okay, there is no need to do the full calculation, and it is even more than this value. Okay, so even if it is coming out to be 5.1 and it is plus than this, then there is only one option which can satisfy this condition, and that is 5.5. Now if you look at the solution which is provided by Made Easy, and if you solve this in exam, then as soon as you take a look at this WLQ divided by 48 EI, then you have to do root over G by delta, then you have to do 1 by 2 pi also. You will get confused and you will get demotivated and you will leave this question. But in reality, if you try to solve it, you can do the approximations very easily. Okay, so that is how we get a approximated answer, which is 5.5, and that is correct also, because we are satisfying all the conditions which we are taking as approximations in this particular question. Now let's take one more question and see how exactly can we apply approximation in that. So this is the question number 42, in which the equation that we need to solve over here is for S value. Okay, you can read the question later, and what we are given is omega is equal to 2 pi into 480 divided by 60, and omega n is equal to root over 3s divided by 35, and one more condition is for transmissibility, that is f by f naught is equal to 0.1. Now they have unnecessarily provided this formula just to make people afraid by looking at this particular thing, but we know that zeta is 0, so this is going to be the final formula. So 0.1 is equal to 1 upon 1 minus omega upon omega n ka whole square and modulus. So there is a modulus, so we are going to assume plus as well as minus. So let's first assume plus. That gives me 1 minus 1 of omega minus omega n square is equal to 10, because this will come out as 1 by 0.1. So this is going to give me omega upon omega n ka square as negative, which cannot be possible. So we are going to assume negative here also. Okay, so that gives me 1 minus omega upon omega n whole square is equal to minus 10, and this gives me omega upon omega n square is equal to 11. Okay, so this is the equation under which we need to provide the values of omega and omega n, then we need to solve for s. Okay, so let's take a look at this. So 11 is equal to omega, which is 2 pi into 480 divided by 60 upon omega n. Upon omega n means divided by 3s divided by 35 whole square. That is giving me the final answer over here. Okay, so let's try to solve this particular calculation. This gives me 11 is equal to 4 times pi square multiplied by 480 square divided by 60 multiplied by 3s, and this will be multiplied by 35, because 35 will go upside. So s value is equal to how much? How much will I get as s? 4 times pi square multiplied by 480 multiplied by 480 multiplied by 35 divided by 11 into 60 into 3. That is the thing that we need to solve over here. Okay, so unnecessarily I am not going to do any calculations here. So we will simply do the things which are only necessary for us. Okay, so there will be a square of 60 also, so there will be one more 60 over here. There is one more 60. Okay, so 60 will cut it as 40. This 60 will cut it as not 40. 8 times it is going to cut over here. Okay, and then 8 times this is also going to get cut over here. Then what I'm going to get is 8 times 8 times 4. Okay, so 64 times 4 multiplied by pi square multiplied by 35 divided by 33. That is the calculation that I need to do. Now we very well know that 64 multiplied by 4 will give me 256, and pi square is nothing but 10, so 2560, and pi square is nothing but 10, so 2560 into 35 divided by 33. So this value is somewhat plus than 1. Okay, so overall my s value should be 2560 and a little bit plus to this. Okay, so let's take a look at the options that I am having, and then we will see which one is correct answer. Okay, so what I was getting is 2560 and just plus than this, and there is only one option which can satisfy this condition, and that is option number A, that is 2.7, because they have taken millimeter here, so 1000 factor is going to be there. So this is how you can do hit and trial in our numerical objective questions. Okay, now let's take a look at very simple questions which can be solved directly without doing much of approximations, much elimination, and much hit and try. Okay, let's take a look at them. Here the second example that we are going to take is question number 100, and in here the calculation that we need to do is root over 2 into 1800 multiplied by 16 divided by 42 into 0.2. This is the calculation that we are going to do over here. Okay, so since it is a root, I can take 16 out. Okay, so 4 will come out. Okay, then from point I can increase 1 0 over, and 2 will cut with 2. Okay, so whatever I am remaining with is 18 into 1000 divided by 42. That is the calculation that I need to do. Okay, again I can take this out, so it comes out to be 40 root over 180 divided by 42. Okay, now let's assume this as 40. Okay, I'm assuming this as 40, so whatever answer I will be getting, that will be a little bit higher. Okay, so 180 divided by 40 will give me a root over 4.5. Okay, 4.5 it will be. Right, now 40 multiplied by a root over 4.5, root over 4.5 is nothing but 2, little bit plus, then whatever number is more than 80, just little higher than 80 is going to be my answer. So this 83 will be my answer. So this is how we can do these simpler questions which may seem harder for us. Number 107, and in here the thing that we need to do is there is an encoder with 10 tracks. Okay, so the calculation that we need to do over here is 360 degree has to be divided into 2 raised to power 10. Okay, so that will give me the degree values. So 360 divided by 2 raised to power 10. Now if you don't remember 2 raised to power 10, then you can simply write 2, 4, 8, 16 and so on. You will get 2 raised to power 10 as 1024. Okay, so the calculation that I need to do is 360 degrees divided by 1024. Okay, now I can assume this to be 1000 only. Okay, so the overall number will be somewhere more than what I get with 1000. Less than what I get with 1000. Okay, so 360 divided by 1000 is nothing but 0.36. Okay, so that number is less than 0.36 and a very little bit lesser than 0.36. So C is our right answer. Okay, so a lot of people will simply take a look at 360 degrees divided by 2 raised to power 10 and they will freak out with this. So they cannot solve this question because it is just beyond their capabilities. But in reality, this is a very simple question. It doesn't even take 10 seconds for you to solve this question and get the correct answer. Okay, so that is how you can solve complex questions which are really easy. So you have to try your best, you have to do your best and try to solve the questions. Okay, so till now we have seen that we can do elimination, we can do hit and trial, we can do approximation in our calculations, and there are some easy questions which are really easy to solve but may seem complex initially. But now is the time to take a look at the questions which you should leave in your exam, because not every question deserves your time. Okay, so let's take a look at those questions also. So such example is question number 19. In this question, the calculation that you need to do is very complex and you cannot solve that within limited time that you are having. Okay, so this is the calculation that you need to solve. There is 1 minus 3 by 4 raised to power 4, and then there is a cube root also, and then also you have to do one more calculation. And if you take a look at the options, then they are not very far away from each other. So in my opinion, it is best to leave such questions. Okay, so don't take it on your ego in the exam. Just simply leave those questions which are going to consume a lot of your time. In question number 55, if you take a look at this question, then you will realize that you need to do a lot of calculations. First, you need to calculate the value of KF. Okay, then you need to calculate KD. Even if you don't calculate KD, still you have to put this in this calculation. Okay, then you have to calculate this sigma E first, which is having a lot many components and their calculation is going to be hectic in nature. Okay, then again there will be a pi, there will be a d square. So there are so many of these calculations which you cannot do with approximations. So it is best that you leave these questions, because anyways the options gap is not very high. Okay, now if we take a look at question number 22, then you will realize that the number of calculations is very high. They may be easier, but you have to do a lot of calculations and you have to do approximations. And if you make a mistake anywhere in those calculations, then your answer is going to be wrong. Okay, so for example, in here first you have to calculate epsilon h, epsilon l, then based upon that you have to calculate mu value, then you will have to calculate E value, then you have to calculate P value, again putting that into epsilon h formula. So the number of calculations is very high. It is only wise to leave this question to be solved in end of the exam if you have any time left with you. Now let's talk about the bonus tips that we discussed about. The very first thing that you need to understand is never solve steps. In any calculation, try to get final step in terms of the numbers itself without solving anything, and then do single calculation, because that way you will have to do lesser number of approximations and the accuracy of your answer will be much higher, and you have to do less calculations. You will save some time also. So never solve steps, only solve single step that is in the end of your calculation. That will give you better answer. The second thing that you need to remember is do not use decimals, use fraction values. Okay, even if it is possible to convert a decimal number into fraction, then do that. For example, if you are given 0.314, then convert it into 22/7. Okay, if you are given a number, let's say 0.166, then convert it into 1/6. If you are given 0.33, then convert it into 1/3. That way your calculations will be easier. Okay, so don't solve the steps. Don't solve the decimals, try to convert them into fractions if possible, otherwise not. Then do approximations, and approximations are always easy. I have already shown you how to do the approximations. The third thing is you should try to do full calculations. So as I shown you in easier questions, they may seem complex, but if you try to do the calculation, then you are going to get the correct answer. So never leave a easy question in the middle unless you are sure that this is very complex question and that is going to take a lot of your time. Try to solve the question completely. And finally, practice makes everyone perfect. So the more number of numericals you practice without calculator, the easier these calculations are going to be for you. Okay, so practice as many questions as you can, practice as many numericals as you can without using calculator. These are the things that you need to remember in order to solve numericals more accurately and correctly. Now in ESE 2020 prelims, believe me, there were only 3 to 4 questions which needed a lot of time and rigorous calculations. Other than them, there were no questions which could not be solved within given time. So do not think that ESE questions are too hard to solve. Do not think that they cannot be solved without calculator. Simply do practice, solve as many numericals as you can, and try to solve them in your exam also. Okay, if there is a thinking in your mind that ESE questions are very hard to solve, please remove that thinking and do practice. That is the only way how you are going to solve numericals in your exam also. Okay, so these are the things that are important for you to understand and solve numericals very easily and get correct answers. Well, I hope the tips were useful for you, and the video got a little lengthier because I solved the questions, but I hope it was worth your time, and thank you for watching the video. Good luck for the exam if you are preparing for any, and thank you.